Okay, so let's get started with 6.5. Here we go. The law of sines. The trigonometric functions can also be used to solve triangles with no right angle, and that's what we're going to do today. And there are 4 cases that we're going to look at, case 1 and 2. For case 1 and 2, we're going to be using the law of sines. Case 1 is one side and 2 angles. Case 2, 2 sides and the angle opposite one of these sides. Okay, so I want you to write down these cases, especially 3 and 4, because we're going to use the law of cosines for that, and we're not going to repeat the cases in the next section. So write down case 1 and 2. Okay, so let's take a look at case 3 and 4. Write down case 3 and 4 as well. We'll need that for our next section, which where we're going to use the law of cosines. Okay, so case 1 and 2, that's what we're going to use in this section. We're going to work with case 1 and 2, and we're going to solve it by using the law of sines. So here's the law of sines. So the law of sines says that in any triangle, the lengths of the sides are proportional to the sines of the corresponding opposite angles. Okay, so you want to write down the law of sines because we're going to use it in our next example. Okay, so let's take a look at an example. But before we do that, to make this process easier, we're going to follow the following labeling. We're going to label angles with capital letters. So capital A, B, and C, that's how we're going to label our angles. And then the opposite side of the angle, lowercase of that letter. So if the angle is capital A, the opposite side is going to be lowercase a. If the angle is capital B, the opposite side is going to be lower b, and so on. So here's our first example. A satellite orbiting the Earth passes directly overhead at observation station Phoenix and Los Angeles, 340 miles apart. At an instant when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix and 75 at LA. How far is the satellite from LA? Now, what we want to do is we want to do a diagram. We want to draw a triangle and try to label everything. So I'm going to give you a minute to think about this example, draw your triangle, and then we'll talk about how to solve it. Okay, let's take a look at the diagram. Here it is. We have our triangle ABC. We have angle A is 75 degrees, angle B is 60 degrees, depending how you label the triangle. And first thing we want to find is what? What should we find first? Okay, so let's find angle C, because we already know two angles. So in order to find a third angle, we'll have 180 minus 75 minus 60, and that's going to give us 45 degrees. Okay, so we're going to use the law of sine that says sine of B over lowercase b equals sine of C over lowercase c. So on the next slide, we have sine of 60 degrees over lowercase b equals sine of 45 degrees over 340. So what is b? Here we can cross multiply to make the process a little bit simpler. So we're going to cross multiply. Let me just show you on the side. We're going to cross multiply. So here we have B sine of 45 degrees is equal to 340 sine of 60 degrees. And all we have to do is divide by 45, sine of 45. So B is 340 sine of 60 degrees divided by sine of 45 degrees. So that's how we get the next step. And now we know what sine of 60 and sine of 45 is from our table. We can go ahead and look up those values in our table, then multiply by 340 in the numerator, and we can put that all in the calculator to get approximately 416 miles. Any questions? Okay, no questions. Then let's take a look at another example. We want to solve triangle ABC where angle A is 45 degrees, side A is 7, radical 2, and side B is 7. When we say solve the triangle ABC, that means we need to find everything, all missing angles and the missing side. So I'll give you a time to work on it. Okay, let's take a look at this problem here. Here is our triangle, and let's start with finding angle B first. So let's say we want to find angle B. We know that sine of capital A over lowercase a equals sine of capital B over lowercase b. So what is sine of B? Sine of capital B is B, lowercase b, sine of A over A. Now we plug in for A, B, and a capital A, and now we get these values from our table. So sine of 45, we know it's radical 2 over 2. 7 and 7 will nicely cancel out for us. And then radical 2 and radical 2 will nicely cancel out as well. So now we have 1 over 2. But that is not our answer. This just tells us that sine of angle B is 1 over 2. So now we're looking for angle B. So the question is, which angles B have sine of B equals 1 over 2? So what I'm going to use the unit circle. I'm going to use the unit circle to see if we can figure it out. Sine of B, it's a y value, so we're looking at y equals 1 over 2. So we have something in, we have an angle in quadrant 1 and in quadrant 2. They're both positive, right? Sine is positive in quadrant 1 and in 2. Now, from the table, if you look at the table, you'll get 30 degrees. You get 30 degrees from the table. You'll know that's 30 degrees. And in quadrant 2, that's going to be 150 degrees because 180 minus 30 is 150. Now, so we have two choices. It's either 30 degrees or 150 degrees. If we choose 150 degrees as our answer, and we already have this one at 45, so let's say if this one is 150, and this one is 45, that's already more than 180, and we still need another angle. So 150 is not going to work. That means we need to go with 30 degrees. So our answer is going to be 30 degrees. So angle B is 30 degrees. Now we don't have to repeat the process to find angle C, because we can easily obtain by taking 180 degrees minus 30 minus 45, which is going to give us 105 degrees. Now let me label these 30 and 105. So this one here is 105, and this one here is 30. So all we need now is side C. We're looking for side C, and to find side C, we're going to use sine of B over B equals sine of C over C. Therefore, lowercase c is lowercase b sine of capital C over sine of capital B. Again, we plug in for B, C, and capital B. We get this. We know that sine of 30 is 1 over 2 from our table. We don't have the value for 105, so we're going to use our calculator. Make sure your calculator isn't in degree mode, not the radian mode. So make sure you switch that to degree mode. And the answer is going to be approximately 13.5. So side C is approximately 13.5. Questions? So before we move on to our next section, we're going to actually do some problems. So let me pull up a whiteboard. Okay, perfect. Now let me put up some problems. The first problem we want to work on is going to be find side X, and here is our triangle. This is A, this is B, this is angle C. This one is going to be 98.4. This one is going to be 24.6. That's all degrees. And this is my side X, and this length is 374. And we're looking for X. I'll give you some time to work on this. Okay, so let's take a look at this one. First, we want to calculate angle C. Angle C is going to be 180 degrees minus 98.4 degrees minus 24.6 degrees. So angle C is going to be 57 degrees. So angle C is 57 degrees. Now we can have sine of capital C over X equals sine of capital A over lowercase a. Sine of capital C is going to be sine of 57 degrees over X. We don't know what X is, we need to find it. Sine of capital A is going to be sine of 98.4 degrees. and over lowercase a, which is 374. So now we cross multiply, we get 374 times sine of 57 degrees is equal to x times sine of 98.4 degrees. So what is x? X is going to be 374 sine of 57 degrees over 374 over sine of 98.4. So 374 sine of 57 time over sine of 98.4 degrees. We're going to use our calculator to find this. And what do we find when we use our calculator? Did anyone calculate this? To two decimal places? Anyone? Ooh, 317.06. I got 317.06. 317.06. Okay, 317.06. Thank you very much. 317.06. Any questions? Okay, I'll give you a minute to copy this if you need to copy it, and then I'll put on another problem. Okay, let's take a look at a different problem. Okay, let's take a look at this problem. So we're going to use sine of capital C over lowercase c equals sine of A over lowercase a. So we have sine of theta, which we're trying to find, over 36 equals sine of 120 degrees over 45. We cross multiply this, so we get 45 sine of theta equals 36 sine of 120 degrees. So what is sine of theta? Sine of theta is 36 sine of 120 degrees over 45. And therefore, sine of theta is approximately 0.693. But we're not looking for sine of theta, we're looking for theta. So what is theta? That's going to be inverse sine of 0.693. And we're going to use our calculators to get this answer. And when we do that, we get approximately 44 degrees. Questions? Okay, I'll give you a minute to copy this. Okay, so the question is, how do we press inverse sine in a calculator? Okay, you got it. So, but let me just say it so everyone knows. It's going to be second sine key. Sine is above comma, so 7, comma, then sine. You press second sine, you get the inverse sine key on your calculator to get the answer. Okay, I'm going to write another problem. So let me erase this. Okay, let's take a look at this one. We want to find angle theta. So let's write this. I'm just going to write sine of theta is going to be 56.3 sine of 67 degrees over 80.2. And that is approximately 0.646. Therefore, what is theta? Theta is going to be inverse sine of 0.646, which is going to be approximately 40.3 degrees. Any questions? Okay, so let's move on to 6.6, law of cosines. Okay, so here we're going to talk about the law of cosines. That's case 3 and 4 from previous slides. The law of sines cannot be used directly to solve triangles if we know two sides and the angle between them, or if we know all three sides. So case 3 and 4, if we have case 3 and 4, then we want to apply the law of cosines. And here they are. So you might want to copy this because that's what we're going to be using for our next examples. So I'll give you some time to copy this. Okay, so let's take a look at some examples. The side of a triangle are 5, 8, and 12. Find the angles of the triangle. So let's start with angle A. Let's say we want to find angle A. This is the setup. We're using law of cosines. We're solving for cosine of A. When we solve for cosine of A, this is what we get. And at this point, we want to plug in for B, C, and A, which was given to us. And we should get 183 over 192. I'll leave this slide on for a few minutes so you can take a look at this. Okay, so when we divide 183 by 192, we get 0.953125. And that tells us that cosine of A is that, but not A. So in order to find A, we're going to use inverse cosine function on our calculator to find that A is approximately 18 degrees. Okay, so go ahead and try to find angle B. Let me maybe pull up the slide where you have the information. So try to find angle B using law of cosines, and we'll go over it in a minute. Okay, let's look at angle B. How would we find angle B? Here's the setup. Plug in for A, B, and C. Oh, this is for A, sorry. Here's the setup for B. When we simplify this, we get 0.875. And we would do the same thing for angle C. We would do the setup. And we would get negative 0.8, negative 0.6875. Next slide is going to show us both answers. So I'm just going to leave this slide on for a little bit. So you can copy this if you need to, or double check your answers, and then I'll show you what angle B and C are. Okay, so here are angles B and C. Angle B is 29 degrees. Angle C is 133 degrees. We didn't have to calculate all three angles this way because once we have two angles, we can easily obtain the third angle by subtracting it from 180 degrees. But it's always good to do it this way to check your work. Any questions so far? Okay, so let's do some exercises. Okay, so let's take a look at the answer. I'll do the setup. So we have x squared is equal to 21 squared plus 42 squared minus 2 times 21 times 42 cosine of 39 degrees. So x squared is going to be 441 plus 1764 minus 1764 times cosine of 39 degrees. So that in that case, x squared is approximately 834.115. But now we have to solve for x, because that was x squared. So we take the square root of that. Square root of 834.115. And in that case, we get x is approximately 28.9. Questions? Okay, I'll leave it on for a little bit and then I'll erase and put another problem. Okay, here's another problem. Okay, let's take a look at this problem. So what do we have? We have 37.83 squared equals to 68.01 squared plus 42.15 squared minus 2 times 68.01 times 42.15 times cosine of theta. Okay, so what do we get? We get cosine of theta equals 37.83 squared minus 68.01 squared minus 40.15 squared over negative 2 times 68.01 times 42.15. So cosine of theta is approximately 0.867. Therefore, theta is approximately inverse cosine of 0.867. So now when we put this into our calculator, we should get approximately 29.80 degrees. Any questions? Is everyone okay with the concept? Is everyone okay with the law of sines and law of cosines? Is everyone okay? Yes, one person. Okay. Yes, 2 people are awake. Great. Yes, 3. 3 out of 14 people are awake. Excellent. That's a good result. Okay, so that said, if you don't have any questions, then that's where we're going to end, and we will meet again on Tuesday. We're covering 7.1 on Tuesday, which is going to be trigonometric identities. Do we have homework? Yes, we have homework for each lesson. Everybody's on WebAssign. All homeworks are assigned based on the lesson. So homework for 6.5 and 6.6, yes, it should be on WebAssign. If it's not there, let me know, but all the homeworks are already assigned for the entire semester. And what was I going to say? Exam 3, again, May 5th, and then final May 14th. Yes, they're assigned for much later dates. Yes, I've mentioned that before because of the fact that we're doing online of the class, and because of everything that is going on, I've given an extended time for homework. So now we have about, like, I don't know, I think I set it up for a week and a half or 2 to 2.5 weeks for each homework. So the best way to keep up with homework is to do the homework right after class, and then you're done. You don't have to look at the due date. You'll just get it done right after class. But yes, you have more time for each homework now because of what's happening. So I give you more time. Exam grades for test 2 will be posted either later on today or tomorrow. So I'll be posted. So yeah, the due dates are a little bit shifted, and then there was a recess, so I had to shift more due dates, more homeworks for later dates. So some of the homework fell on the same day. But as long as you're on top of each assignment, so after each lesson you do your assignment, then you don't really have to worry about the due dates, because even though they're 2.5 weeks or 2 weeks, you have all this time to do it. If you do it right after class, you'll be okay. But yes, we have a few more lessons to go, so all the assignments should be on WebAssign. Exam 2 is going to be either today or later on tomorrow. You'll have the grades posted. I'm still looking over a few exams. Okay, and then exam 3 is going to be on May 5th. It's going to be during class time, so you have to start at 10:05, And then your final is on Thursday, May 15th, and it also is going to start at 10:05 in the morning. But I'll send updates via email. Any other questions that I can answer for you? Okay, if there are no other questions, then I'll speak to you guys on Tuesday. Have a wonderful weekend and stay safe. Will it be the same amount of time as the class time? Yes, you'll have the same amount of time as the class time for the exam. It will end at the end of the class, yeah. Okay, thank you everyone.